Hey guys, so this video is about exponential equations, and I'm going to come back to these steps when I get a couple more problems in, because these first ones are actually exceptions. So normally we're going to use logarithms to solve the equations, but if we can get around it, it's nice. So there's an easier way to do these particular style problems. With the 27 and 9, we saw it in an earlier section, I think it was 10.3, where if we could write it with a common base, we could equate the exponents. And so that's what we're going to do here, and it's going to save us a ton of work relative to doing the steps out for sort of the more traditional solve. So this would 27 I'm going to write as 3 cubed, and it'd be times the 3x minus 1. And then the 9 I'm going to write as 3 squared, and then x plus 2. And so since I have 3 to this equals 3 to that, then this equals that. So I'll just, for space, I'm going to distribute as I write it down out here, but basically I'm dumping the bases. And then it's going to be 9x minus 3 equals 2x plus 4. I'll bring the 2x over, and that'll give me 7x minus 3 equals 4. I'm going to add the 3 over, so 7x equals 7, and x equals 1. So much easier math. This one a little bit tricky. So the 49, you can kind of see this would be like 7 squared. So what I'll do is I'll write it as 7 to the 3x equals a very sneaky 7 to the negative 2. So if I write it with a negative exponent, I can bring it up, and then the 7's, I can dump those and just set the exponents equal. So 3x equals negative 2, and x equals negative 2/3. And then these are the ones I'd have you guys try. So for 8, we'll make it 2 cubed, 2x minus 1. And for 16, we're going to make it 2 to the 4th, x plus 3. So then 3 times 2 is going to be 6x. 3 times 1 will be minus 3. 4x, and 4 times 3 equals 12. And again, x is to one side, numbers to the other. So I'll bring the 4x over, and that'll give me 2x minus 3 equals 12. Add this 3 over, so then I'll have 2x equals 15, and then divide the 2. And then this one, so 8 to the 2x, I want to get these both base 2. So 8 I'm going to write as 2 cubed to the 2x. And then that is the same thing as 1 over 2 to the 1. So I'm going to write it as 2 to the negative 1. And then bringing these down, 3 times 2 is going to make this a 6x equals negative 1, and divide over the 6. And negative 1/6. Okay, so for number 5, there's nothing clever I can do between 10 and 4. I can't write these with a common base. And so then that's where we're going to need to do kind of the steps. So first step is to log both sides of the equation. So that's going to just look like log 10 negative 3x equals log 4. And then second step is to bring the exponent down in front of the log. So it's using that property 3 where I can bring the r down front. So then negative 3x comes down here. And what that did was it got the x down out of the exponent where I can get at it now. And then step 3 is solve the result. And then remember to let your calculator do most of the work. I'll show you what that means in probably another example or two. On this one, there's a nice little simplify here, which remember that's an invisible 10. So log base 10 of 10, what do I raise 10 to get 10 would just be 1. So this side is really just 3x, which makes it a little bit simpler, and log 4. And then to get x by itself, I'll divide both sides by negative 3. And then x equals this in the calculator. And let's see. If that makes it in the calculator, I got negative 0.2007 to 4 decimals. So let's see, for this one, let's get the 12 out of there. So I want to isolate this. I want to make it look like this basically. And I got this 25 that's multiplying into 12 adding. So those I can simplify before I do this log step, which will make it way, way easier. So if I do that, now I have 25 times 3, 0.4x equals 40. And then the 25 is multiplying, so I'll divide it over. So 0.4x and 40 over 25 would be 1.6. So now I'll log both sides because I have this as simplified as I can. And that allows me to bring the exponent down front. And then I'm going to divide by everything but the x, because log 3 is just a number and that 0.4 is just a number. And that's going to get x by itself. And then that cancels, so I have x equals, and then this into a calculator. If you're doing it all at once, make sure you get parentheses around the bottom with the times sign right there when you do your divide. Otherwise, it'll divide by the 0.04 and multiply by the log 3. And so if you get this in the calculator correctly, I got 1.0695. So number 7 involves e, so that means we're going to want to use a natural log with that. Anytime you have a base 10, you want to use common log base 10. Anytime you see an e, you want to use ln, because it'll make the step simpler. So here I'm going to divide both sides by 8. Just again, isolating the exponential piece. So the 8's reduce. And I have e to the 4x equals 2.5. And now log both sides, but I'm using ln because of the e. And then I can bring the exponent down front. And then here's how come you want to use natural log, is because at least at this step, natural log of e, that equals 1, because what do I raise e to get e would be 1. So it just makes this division step a little bit easier. I divide out the 4 on both sides, and x equals, let's see, I got 0.2291. And then these next 3 are the ones that have you guys try. So here, this one's a little tricky, so we're going to go, it's already isolated, so I'm going to just log both sides. And I bring the exponent down front. That's at step 2. And then I'm trying to get x by itself, so I could distribute this. That would work. Or I could just divide it over. Since we're looking for a decimal, I really think this is the easier way. It looks ugly when I keep solving it, but the idea is to you're not trying to get to the exact solution here. If I wanted the exact solution, I would distribute, and then I would add this piece over and divide by whatever is with x. But since we just need the decimal approximation, from right here, this is going to be like that. And then this piece is just some number. And so then once you're there, like I said, this is just a number. So you can go log 18 and then divide it by log 4. Enter. And so that makes some number over here. 2x minus 3 equals 2.08 with some stuff. But with that still on the screen, you know you're going to add the 3, so just go plus 3. And now you have 2x equals that, so you're going to divide by 2. And then that's your number. So x equals 2.5425. So number 9 has this 50 in front, so we're going to get rid of that. And that's going to get us 9 to the negative 2x equals 8 over 5, so that would be 1.6. And no 10s or e, so we'll just log both sides. You could also natural log both sides, it wouldn't matter. And then bring the exponent down front. And then divide out everything except the x. So negative 2 log 9, and same on this side. And all that cancels. And again, just got to get that in the calculator. And you can do, if you're having a hard time getting the parentheses in the right spot, you can just do log 1.6. Here, I can do it right here. So log 1.6, close that, divided by negative 2, and then hit equals, and then divide by log 9. And it'll just copy your answer. Equals. And so that equals x is negative 0.10695, so that will be 70 to 4 decimals. So we'll get this 120 out of the way. So that cancels. And then I'm going to have e to the negative 0.12 and then 5x equals 0.25. And then I can natural log both sides since I have an e. And I can bring this down front. And then remember ln e right here, this equals 1, so that piece drops out. And then we can divide out the negative 0.005 on both sides. And that gets us x equals, let's see, that one comes out 277.2589. Okay, and these last few problems involve compound interest formulas. And so let me kind of talk through what the pieces are. So A is the amount after 2 years. So we're going to invest some money, that's P. So that's the dollars invested, and we're going to get about some amount later after some amount of time. R is our rate. N is the number of compounding periods per year. So like if it was quarterly, N would be 4. If it was monthly, N would be 12, for instance. If it was annual, N would be 1 because it's only compounded once per year. And then T is the amount of time the money was invested. And we have two formulas that compounds N times per year, so that's like quarterly, monthly, daily. And then we have continuously compounding, and it's that continuously that you'll see in the problems that tells you you're using this formula, which means every moment the money is compounding. So number 11, how long does it take for an amount of money P to double itself if it's invested at 7% interest compounded monthly? Round your answer to 2 decimals. So they didn't even tell us how much P is, but that's okay. So if we're investing P, we're going to get out, and it's going to double, we're going to get out 2P. And you'll see it doesn't really matter how much it was, it's the same time to double, no matter how much is invested. Our rate was 7%. Monthly, so that's going to be 12 compounding periods. And then this is really small, but it's to the NT up there. So it's to the 12 times time. And then from there, the first thing I would do is I want to isolate the exponential piece. So I'll divide both sides by P. And that's why it doesn't matter. That would just divide out and be a 2. So if we put in $1,000, we get 2,000. It divides and the ratio is the same. And then I'd also maybe throw that in the calculator. This one's kind of ugly, but it would be like 1.0058, goes on forever, to the 12t. And then from here I can log both sides. I think I'll use natural logs this time just because I can. again, big decimal. I would probably just write like number, and then when I got down to do the calculation, then I would type this in the calculator. Excuse me. And so now I can bring this down front. Oops. And again, don't round this, just type this in at the end. And then, so right here, we would divide all this over. So I'd have 12 ln 1.0058, 12. And then that cancels, and then that's what goes in the calculator. And if that goes in there well, you should get t to be 9.94 years to 2 decimals. Number 12, how long will it take $2,000 to grow to $3,000 at 6% compounded continuously? So that was the other formula, is A equals PE to the RT. So we're putting in 2,000. We're getting out 3,000. And E is that 2.718 number. 6%, so 0.06 to the T. And we're looking for how long. So first thing I do is isolate the exponential. And now I got 1.5 on this side equals E 0.06 T. Natural log both sides. And bring the exponent down front. And then ln E equals 1, so that piece drops out. And then I can just divide over the 0.06. And plugging that in the calculator, I got T to be 6.7578. 13 and 14 are the matched problems. So how long will it take a sum of money to triple if invested at 8% compounded quarterly, round to 2 decimal places? So how long will it take it to triple? So if I put in $1, I would get out $3, right? So I can just think of this as a 1 and a 3, so I don't have to do the division, and that's because that ratio is always the same. If it was 1,000 and 3,000, when I divided, this side would still be 3. And then the formula went 1 plus the rate, which is 8%, over the number of compounding periods. So the n, quarterly, that's 4. And then to the nt, so to the 4t. And I'm going to clean up that decimal a little bit. I'll drop the 1 now. And so that's going to make this be 1.02 to the 4t. And then I'll just log both sides right here. I can bring down the 4t. So this is ln 3 equals 4t ln 1.02. And then from there I can divide out everything but t. So 4's cancel, natural logs cancel. And then the calculator should get you 13.87 years. And last one, so how long will it take 25,000 to grow to 40,000? So 40,000 out, 25,000 in at 11%, compounded continuously. And so that's our E to the RT, so that'll be 0.11 T. And then I'm going to divide over the 25 grand. And that gets, I liked 1.6 today. I made the notes, I guess, because another 1.6. e to the 0.11t, and then from here I'll just natural log both sides. And I can bring this down front. And ln e is 1, so that drops out. And then just divide over the 0.11. And then that in the calculator I got to 2 decimals, 4.27 years.